that's not necessary, because if we just put if comparison result, if we just write if comparison result, that's going to give us the same effect as if we write true. Otherwise, if comparison result isn't true, then this if statement will not run. We then need to specify some kind of body for this if statement. So in other words, where do we branch to? What happens? What code do you want me to run if that condition is true? So we can create a body here and put in that log function. And there you go, we now created a branch. So if comparison result is true, we're going to print the console, otherwise we're not going to. Now there are quite a few interesting things we can actually talk about, even with this code that we've written, because there's just so much going on. So let's kind of run this program first, see what happens, and kind of so if I hit F5 right now to run my program, you can see that I do get that hello world. However, if I change X to be something like 6, and I hit F5, nothing's actually going to be printed. If we put a breakpoint here, now I covered breakpoints and debugging in my previous video, so if you haven't checked that out, you're going to want to check that out. There'll be like a little thing on the screen or something. Link will also be in the description. We're going to be using a lot of techniques from that video in this video, so you're going to want to check that out. I'm going to hit F5 now with my breakpoint set. Let's close this memory view here. And then I'm going to hit F10, we're going to see that X is in fact equal to 6, where of course comparing it to C is X 5. Of course it's not 5, so if I hit F10, comparison result will be set to false. And finally, if I hit F10 over here on this if statement, it will evaluate that if statement, and you can see it jumps right into this C again, so it never crossed this line of code. This line of code was at fault because we basically said, hey, only log hello world if comparison result is true. If we want to take a look deeper into behind the scenes of what's actually happening here, what CPU instructions we're running, we could compile this to assembly and inspect the output of assembly. However, there's actually one more thing we can do by debugging, and that is do the disassembly of this current code. So if we hit F5 to run our program with a breakpoint set, what I can do is right click here. This is once my application is deployed, right? I can right click here and select code disassembly. And then you can see I jump into this view where we have both our source code and then the associated assembly instructions with that source code. So in other words, our compiler can compile this source code, this one, and this source code for all of these. And we can actually step through this assembly line by line and even take a look at what the registers in our CPU actually contain. So it's pretty cool. This disassembly view is actually amazingly useful when you're trying to debug either source code that you don't have access to, so in other words you have to resort to actually debugging CPU instructions. That's an absolute nightmare, by the way. Try and avoid that as much as you can. But also it's really useful to quickly see what code the compiler has actually generated instead of setting up that whole outputting to a file stuff that I covered in my How C++ Compiler Works video. Instead of setting all that up, we can just kind of look at the disassembly view. And so back here, you can see that the first thing that's happening here. Now I'm not gonna just spend half an hour now teaching you guys assembly. I do intend to make some videos on that in the future. I think if you guys want that, you can leave a comment below, because I get asked this a lot. But basically, I'm not going to spend a bunch of time now explaining how everything works. I'm just going to kind of gloss over this. So if you are interested and you want to know more, you can either Google it or you can drop a comment below, and I'll try and make a video sometime soon in the future. But if we look at this code, you can see that what's happening here is we're actually loading a register with a certain value. This move instruction, mov basically just means move. We're moving the value 6 into this register, right? So you can think of this as we're setting that X variable to be 6. And if we hit F10, we'll get to the next instruction. Now, this is our actual Boolean statement, right? So what we're doing is we're actually loading 5 into that same register. Now this is interesting because the compiler has decided to do some pretty fancy things with our code. So if we keep reading this, the next instruction is going to be a JNE, which means jump not equals. So in other words, if this comparison fails, right now this comparison, all it's really doing is comparing those two values, 5 and 6. If they're not equal, we're going to be jumping to this memory address. Now the memory address is actually this value here, 01B5 9B7, right? So if we just look at the end of that, really, 9B7, you can see that it's actually this line of code. So if these are not equal, we're going to jump to this line of code. Now when we know that it's not equal, so if I hit F10, you can see that our instruction pointer, so this yellow